Okay, this is part 2, looking at Unit 5C, statistical tables and graphs. I'm not going to look at this idea this text calls binning data. Sometimes you'll hear this referenced as, or called, breaking things into classes. So when you deal with quantitative data categories, it's often useful to group into classes or bin the data into categories that cover a range of possible values. So for example, if you're looking at a table of income levels, it might be useful to create bins covering 0 to 19,999, 20 to 39,999, and so on, rather than trying to have one frequency for every possible income. You can group them into what we call classes or bins. And then the frequency of each bin would then be the number of people whose incomes or whatever would fall into that bin or category, to be consistent, bin or class. So we've got here some data that we want to use, and we want to use 10-point bins. So we want to go from 90 to 99, 80 to 89, etc. to grab all of these. So we're going to put a bin here. So the first one is 90 to 99, and then 80 to 89, 70 to 79, and then 60 to 69 would be the last needful, because our lowest value in here is the value of 60. Okay, so then once we've got our bin or classes made up here, alright, let's try this again. So we've got our bin. Then we can look at the frequencies within that bin. So from 90 to 99, you go through the data and you just count how many fall in that range of 90 to 99. So as I come through, I'm going left to right on the top first. So 99 is going to be in there. I'll just highlight them. 95 is going to be in there. 98, 90, 92, 96. So that is a total of 1, 2, 3, 4, 5. So there's a frequency of 5 that fall into that bin. Okay. Then again, you'd count 80 to 89. If you count through those, you would find 5 as well. And it turns out that there are 5 in each of these categories. So frequency of 5 for each bin. And then the bin should add up to the total numbers when we add up, and we've got 20 data points there, so there's 20 when we add them all. And then if we look at the relative frequency, okay, the relative frequencies here, they're actually all going to be the same. So 5 out of 20, which is a quarter, or 0.25. So the relative frequency of all these is 0.25. So that does add up to 1. So relative frequency is good there. And then our cumulative frequency, start with 5, and then 5 plus 5 is 10, plus 5 more is 15, plus 5 more is 20. So our cumulative frequency totals out to 20, which is the total frequency as well. So we are good there. So that's just a brief overview as to how you will be binning data and putting them together in what we can call classes is another term you'll hear frequently. Okay, just a quick note here, bar graphs and pie charts. We're not going to do any examples on these because they are so well known, and they're introduced at such a early time in education. And so as you're looking at bar graphs, they can represent frequencies, they can represent relative frequencies of category, and the higher the frequency, the longer the bar. And then you can also make your bars go vertical, they can go horizontal. So in your text, if you look at figure 5.3, you can see some information there. But one of the key things when you're looking at bar graphs or pie charts, is make sure that things are labeled properly. So, if you're making a frequency table and a frequency is marked along the left axis, relative frequency along the right axis, you just want to make sure that you have clear labeling. So as you're making these bar graphs, that it's clear to the reader what each thing means, because without those labels, the graph is just, it doesn't have a lot of meaning. It's open to interpretation. So whether it's a pie chart or a bar graph, make sure to label it properly and to try and do your best to draw it to scale. If you're drawing a pie chart and it says 50% for one category, you want to make sure that you don't say that this is 50% and draw it in this form, because that's very deceiving. So just make sure that you try and scale those things well. Now, one thing that is used frequently, one type of bar graph that's used frequently is what we call a histogram. And it goes kind of hand in hand with what's also known as a line chart. Okay, we use these for ways to represent data. So for quantitative data categories, there are two very common things: graphs, histograms, or line charts. A histogram is actually, at least from my experience, I see histograms probably at a 5-to-1 ratio, if not more. But histogram is just a bar graph in which the data categories are quantitative. The bars must follow the kind of natural order. So if you're numerically, you want to go from low to high. And the widths of the bar have a specific meaning. In all of ours, we're going to try and keep the widths the same for simplicity. But we can look, here's an example of a frequency histogram. Okay, we notice we label the frequency on the left-hand side, the scores on the bottom, and we can see from 70 to 75 there were 4, and then between 75 and 80 there are 7 data points. 80 to 85 there are 3, and then 3, 2, and then 1. That's just a clean way to look at a set of data. Again, that's a frequency histogram, which is just a bar graph that we use to represent data. Now, if we look at the line chart, okay, the line chart has these points right here. Okay, and if you look at these points, would basically be kind of right in the middle of where these bar graphs are. So if you were to do your best tracing here, this is where then it tails off to 0. This is where the connection is between a bar graph that we call a histogram and a line chart. They each have their own benefit. If you're looking at a time series graph of how something has appeared over time, a lot of times you will see the line chart, and so that time series graph is a specific line chart. It can also be a histogram, but in that case where time is on the horizontal axis, because time is continuous, and it just shows you what it looks like. If you're looking at the stock market, for example, stock market does use the time series graph, how things occur over time. So that's just the basics of a histogram and a line graph. So on this question here, we have the following frequency table. Let me just check my time actually real fast. Yeah, we're good. Categorized Nobel Peace Prize winners in literature through 2016, and it's by their ages that they receive these awards. We want them displayed in a histogram, and then notice any patterns or trends that we see as we're looking at this. So the first thing we're going to do is we're going to kind of create the axes here for our bar graph, our histogram, and on this side, this is going to be the, we'll just say this is the number of winners. So we're going to go 2, 4, 6, and we're trying to make this as even as possible. 10, that one's a little high. 12, 14, 16. We'll go up to 18, even though 19's there, we'll hit 19. And then on the bottom, we're going to write all of our different categories. So these are all of the age groups. So our categories here are below 50, 50 to 54, 55 to 59, 60 to 64, 65 to 69, and so forth. This chart is written in a slightly different way, but this bold line down the middle lets you know that it continues on the next side. So if I look here and I say less than 50, okay, less than 50, there were 9 winners. So what we're going to do is we're going to take our bar graph up to 9 and drop it back down. Then our next category is 50 to 54. And notice that I'm not going to connect these bars because they're not right up against each other. They have that distinct, goes from less than 50 to 50 and 54 to 55. But if they do bump right up against each other, you'll connect these together. But this next one has 10. Oh, that is not straight. Sorry about that. So these are supposed to be bars. The next one goes, so for 55 to 59, jumps all the way up to 18. And then 60 to 64. 64. It also jumps all the way up to 18. I apologize for these bar graphs. It's not the easiest. It's my pencil's sliding all over the iPad here. 65 to 69 comes up, peaks us out at 19. And then 70 to 74 drops us back down to 18. And then you continue this on. I don't have room, but then you'd have a 15. I have room to write the rest, and then you'd come down to a 4 and a 2. But I've run out of room to be able to write. But if you look at this, this would be a histogram. Using technology to draw a histogram is far superior. So as you do this in your homework, you'll be able to use technology. This just gives you an idea as to how you construct it. As we look at this trend, as age increases, we see more Nobel Peace Prizes, and then at kind of 70 to 74, we begin to see a decrease, and then a quick drop off as people age and get into their 80s. So that's just a look at how you'd create that histogram. So if you have any questions, please don't hesitate to let me know. I know my drawings are terrible here, but again, using technology that you'll be able to use in my math lab will make this much more efficient. And that is a look at Unit 5C.